greater than 10.5. And it'd be good to make a note that this is right-tailed.
Okay.
All right, so here is another problem with more numbers in it. This one only had one number in it, so it's pretty easy to figure out which one is or which number to use. It may not always be that easy. All right, here we go. According to the Center on Philanthropy at Indiana University, the mean charitable contribution per households with among households with an income of 1 million or more in the United States in 2005 was 70,072. Research believes that the level of giving has changed since then. All right. Give me the null hypothesis, please. What number goes there?
17,000 and
Right.
that.
Sorry, I don't need a mu zero, I just need a mu. Okay. And then mu, what is the symbol that goes next to it?
Is it that 0?
I'm sorry, say that again.
Because it's a null, it's 0.
No. Like what symbol? We got three possibilities here. Not equal to, greater than, or less than. It's always the same number.
It doesn't. A researcher believes that has changed.
So changed is where we don't know whether it's gone up or down.
Oh, okay. So it's not equal.
Yes. And what is the number?
17,000 and
good. Okay. So here is another problem for you to look at. See if you can write the null and alternative hypothesis for these.
Okay. Decreased. So the mu would be the null, or in other words, the null would be 200,000.
Yeah, you can say the digits, but give me the what goes first here. What about, give me this part or this part, whatever it is. Give me
doing the null as
tell me what to write basically.
So mu equals 200,018, that number, and
Yeah, you can just give me the digits, 218600. That's more than enough.
okay.
Right?
And
And
then
then what's
alternate, since it says it's decrease, it'd be less than.
Same number.
Yeah.
Okay. Are you getting a sense of how to do this?
Yes, this is helping. Are you there?
All right. Yeah, I'm looking for some more problems here that might be beneficial. These are very direct in how they're presenting them. So we're looking for some that are a little bit more challenging, we'll say. But we can come back to that. If I could find yeah, so let me see if I can find a couple more. Scouring the internet here for some problems here. That's not what we want. We'll get to that. Okay, just Another 30 seconds. Hopefully I'll be able to find some problems. That's loading. All right, one more. All right. All right, so this is kind of the way I think a problem might be presented in your classroom. It's not as direct as saying like it's increased, it's decreased. So take a look at that and see if you can write the null and the
Okay,
alternative hypothesis, please.
got it. 2011 average was 183. Actually higher. Oh, okay. So the null would be mu equals $183.
Okay.
It says it's actually higher. That would be greater than the null.
Very good. Okay. All right. So we'll maybe do a few more of these coming up, but let's move to talking now about rejecting and fail to rejecting.
Okay.
Right. So it's a very simple statement. If the p-value is less than alpha, you
Okay.
reject the null hypothesis. So you have to remember this, but it will never just ask you at something this directly.
The hypothesis. Okay.
And then similarly, if the p-value is greater than alpha,
If the p.
you fail to reject the null hypothesis.
Okay.
Okay, so here's a simple example. Just a few of these. The p-value is 0.015 and the alpha is 0.05. Do you reject or fail to reject?
It would be. Wait, hold on.
It's kind of like true false. I really can't help here. You gotta decide
Yeah.
on your own.
Yeah, I know. I'm just reading over. The p value is less. Reject.
This one you do reject. Now, sometimes students struggle with how to compare decimals. Um, the correct way to do it is to line them up and you look for the first difference between them to see which is smaller. If you don't like that, you can also do the following. You can take the p-value and divide it by the alpha, 0.015 divided by 0.05. If this number is less than 1, you reject. I don't know if that's easier for you, but that's another possibility.
Okay.
All right. So now let's do another one. Let's say the p-value is 0.01 and the alpha level is 0.1. Do you reject or fail to reject?
Fail to reject.
So is the p-value less than alpha? Is 0.01 less than 0.1? So if it is, you reject. And in this case it is. You have to line up those numbers there. So this one you do reject. Questions about? We're gonna do more examples, but
Yeah.
you're basically comparing this number to this number, and hopefully it's different. So let's say the p-value is 0.055 and the alpha this time is 0.01. Do you reject or fail to reject?
The p value. Fail to reject.
Yes. So this time the 0.055 is greater than 0.01, so you fail to reject. Okay. Questions on that? Thoughts on that?
No, not at all.
Okay. Okay. So the way we make this a little bit more difficult is, let's say I tell you that it's a right tail test. And I tell you that Z is equal to 2.07. You have to use this now to find the p-value. And I tell you that alpha is 0.05. Do you know how to use the Z to find the P? It's okay if you don't. I'm just, you know.
I know how to do it like with a certain formula, but with the Z, no, because we haven't mentioned that.
Okay. You guys haven't been asked to use like a Z table?
Oh, we've been using a Z table.
Okay.
But
And that's what that's what I'm asking. I'm asking, like, are you comfortable using a Z table to look this up?
yeah.
Do you have one available to you to look? I mean, we can get one on the internet too. I mean,
I'm
yeah, I mean, I just want to make sure that you can do this, because this one is a little bit more difficult. So if I snip in this Z table and you're looking for 2.07, do you know where to look in the table to find it?
yes.
Okay.
2 point.
2.07.
Okay. I'm looking at mine now.
Okay.
Okay. I believe it's 0.9808. If I'm looking correctly.
So I'm looking at, yeah, that looks good to me. 0.9808. 0.9808. So that is not the p-value though, because this table gives it to you to the left of that C. And we want the area to the right. So you have to do 1 minus 0.9808.
Oh.
Because it's right tail.
Oh, yeah.
Okay, so what is the p-value? Could you subtract that from 1 for us, please?
Okay. I believe it's 0.0192. If I'm
Okay, so now you got your p-value. Now you got, and you've given you your alpha level. I have to give you both. Is this a reject or a fail to reject situation?
The P. Wait, hold on. It's easier if I. Oh. Reject.
You would reject. Yes. Very good. Okay.
Okay.
Let's do another one here. Let's say this is a left-tailed test at the 10% level of significance. That's alpha, by the way.
Okay.
And you get a Z of negative 1.62. Negative 1.62.
Okay.
So I always think it's important to draw the normal distribution. Yeah, that's 0. That's minus 1.62. We want the area to the left of it. So you've got to look that up in your Z table.
Okay. So negative. It's 1.62. 1.6. It says 0.0526, I believe.
Okay, that's correct. Yep,
Okay.
that's correct. So 10% significance level, what is the alpha? What does that mean for alpha when it says 10%? Do you remember that from?
Yeah, it would be point alpha would be 0.1. Okay, so
So do you reject or fail to reject in this
okay.
case?
So alpha is that. Um, the p-value is less reject.
Do you reject?
Yes.
Okay. So now the last type of example here is if it's a two-tailed test. And
Okay.
let's say you find that Z is 1.83. This time you go to 1.83, but you need the area in both tails. Okay, so it would actually be preferred to look at the area of minus 1.83 and then double it.
Okay, so find minus 1.83.
Yes.
Oh, and then double it. Oh,
Yes, and this time the alpha is 0.05, we'll say.
okay. So what was it again? 0.83 negative. And then just multiply it by 2. Or, okay. Um, or, um, So I don't know if this is correct or not, but for both sides it'd be 0. Wait, no, ignore that. 0.0672 if when after you double it.
Yeah, that's correct. Now compare that to your alpha value. Do you reject or do you fail to reject?
P value. Okay, just give me. And then alpha is uh, uh P value is greater, so fail to reject.
This is a fail to reject. All right, good job on that. Any questions before we move on to type 1 and type 2 error?
No. Okay.
So the type 1 error, very important here. You reject a null hypothesis that is actually true. So I'm going to snip this in here. This is the definition of a type 1 error. Let me know when you get that down.
Okay, I got it.
Okay. So let's say we're gonna go back to a problem we did earlier today. Remember we were looking at this one?
Yeah.
All right, so let's say we find that the p-value is 0.0329, alpha is 0.05. Would we reject or fail to reject?
Reject.
You would reject, okay? But what if later on you find out that the mean is actually 10.5? Okay, so you did your testing, you rejected the null hypothesis, but you later found out that it was actually true. Is that a type 1 error?
Yes.
Yes. That is a type 1 error. So you're going to get a question. The way the question we presented is almost exactly the way that I presented here. It'll tell you that you end up the p-value of this, alpha of this, you would reject, but it'll say, but you actually find out that it is 10.5.
Okay.
All right. So now let's look at a type 2 error. And they're Roman numerals. I don't know why. That's just the way it. All
Okay.
right. And a type 2 error occurs when you fail to reject a null hypothesis that is actually false.
Fail to Okay, I got it.
Got it? So it's very different, and you have to like remember those word for word, and you might even just memorize them, write them at the top of your test. Okay, so we did not do this one earlier. Do you want to try writing the null and alternative hypothesis for me, please?
Okay. Federal law requires that a jar of peanut butter at least yield shorting customers. Um. Okay. So at least. Mu So it would be for the null, it'd be mu equals 32.
Okay.
And and it says at least. So it'd be greater.
The claim is down here in the second sentence. The claim is starting here.
Oh. A customer advocate feels like a certain peanut butter is shorting, underfilling the jar
So how would that affect the?
by less. Okay, I was just.
You have to read, this is the claim.
Oh,
All right,
okay.
now is this left-tailed, right-tailed, or two-tailed?
Left-tailed.
Yes. So let's say you get a p-value of 0.051 and an alpha is of 0.05. Do you reject or fail to reject?
Fail to reject, I believe.
Okay, so you would fail to reject. But what if you later find out that mu um, that they actually are underfilling?
Yeah.
Is that a type 2 error?
Yeah.
Yeah.
Okay.
So let's look at another problem here. So I'd like you to write the null and alternative hypothesis for this one, please.
Okay. Um. So the null would be mu equals 47 point. I mean, what am I making? $47.47.
Okay.
And it says it's different. It doesn't specifically say that it's increasing or decreasing, so it'd be not mu, not equal
There you go.
to $47.47.
All right, good. So now let's say we find that the Z value equals at 2.59. Okay, can you find the p-value that goes along with that?
Okay. Five. 2, 5, 2, 2, 2, 5. Oh, okay, hold on.
And try to think about whether it's a one-tailed or a two-tailed test.
Because, okay, just give me. Oh, wait, since it's really tailed, I gotta subtract it by 1.
Correct.
So, and then since it's two-tailed, multiply it by 2. Okay. I don't know if this is correct or not, but I got 0.0096.
Let's say the alpha is 0.01. Do you reject or fail to reject?
Reject.
You reject H0. And what if you later find out that the monthly cell phone bill is $47.47? Is that a type 1 or a type 2 error?
Type 1, I believe.
It is a type 1 error.
Yes. Okay.
All right. So any questions, thoughts on that?
Uh, no, I think I understand it better now.
Um, okay. So let me try to find one more here, example here. Let's say we find that this is mu is 1100 and HA is that mu is less than 1100. And you find that the Z value is 1.33. sorry, negative 1.33. Could you find the p-value for us, please?
Okay. So it's less than, so the p-value would be 0.0918.
Right, and let's say that alpha is, let's say it's 5% level of significance. What is the alpha value in that case?
It would be 0.05.
Do you reject or fail to reject?
Um, fail to reject.
Fail to reject. Good. And that's, let's say later on, you find out that the mu actually is less than 1100. Is that a type 1 or a type 2 error?
Type 2.
It's a type 2. Good. Okay. Something we've not gotten today are confidence intervals, but we did a bunch of those in previous
Okay.
lessons. The confidence interval is the mean plus or minus the standard deviation. Sorry, the z, you guys using z values, z
Yeah.
alpha, we'll say over 2 times sigma divided by the square root of n.
Okay.
So if as review here, when they give you C, like if they say that they want a 90% confidence interval, alpha over 2 is 0.05, and the Z value, you'll be able to look these up, is 1.645. 95% is 0.1, and that's 1.96. 99% is 0.01, and that's 2. I think it's 3.3. You may want to double check that, but these are readily available out there on the internet, these tables. They have to give you sigma, they have to give you n, they have to give you the mean, and then you just put them into the calculator like we've been doing.
Okay.
I think you're pretty well prepared. I would definitely review our old notes, our old lessons, and see what